When looking at L'Hopital's rule, we are determining the limit of the indeterminate form. We use L'Hopital's rule when the limit of x approaching a of f of x is equal to 0, the limit of x approaching a of g of x is equal to 0, and the limit of x approaching a of the derivative of f of x over the derivative of g of x equals a value, in this case L. Then, if all of these are true, the limit of x approaching a of f of x over g of x is also equal to the same value of L. This can also occur when the limit of x approaching a of f of x is equal to positive or negative infinity, the limit of x approaching a of g of x is equal to positive or negative infinity, and the limit of x approaching a of the derivative of f of x and the derivative of g of x is equal to a value of L. Then, if these are true, the limit of x approaching a of f of x over g of x is also equal to the same value. The first example uses the first conditions presented at the beginning of the video. When the limit of x approaching 0 of sine of x over x is equal to 0 over 0, when taking the derivatives, we can change this into two different functions. The first function is f of x equals sine of x, and the second one is g of x equals x. If we take the derivatives of these functions, we know that f prime of x is equal to cos x, and g prime of x is equal to 1. Going back to our limit, the limit of x approaching 0 with the derivatives of the functions is equal to 1 over 1. This gets rid of our indeterminate form of 0 over 0. Therefore, the limit of the derivative of f of x and the derivative of g of x is equal to 1 over 1, then the limit of x approaching 0 of sine of x over x, being the original function, is also equal to 1. Our second example is the limit of x approaching 0 of 2 sine x minus sine 2x over x minus sine x. If we try to sub in the x value, we see that it equals 0 over 0, this being our indeterminate form. Therefore, we have to take the derivatives of the top and bottom functions. But when we do this, we see that the derivative is 2 minus 2 over 1 minus 1, also known as 0 over 0. We don't stop here. We keep going with L'Hopital's rule to see if it will work out in the end. Because we still have an indeterminate form, we take the derivative again. The limit x approaching 0, negative 2 sine x plus 4 sine 2x over sine x, is also equal to 0 over 0. Once again, an indeterminate form. So we take the derivative one more time. With this derivative, we can see that negative 2 cos x plus 8 cos 2x is also equal to negative 2 plus 8, and the denominator of cos x is equal to 1. Negative 2 plus 8 over 1 equals 6. L'Hopital's rule says that because we found the derivative of the limit of x approaches 0 of negative 2 cos x plus 8 cos 2x over cos x equals 6, the limit of the previous function that we took the derivative from and the limit of the previous function that we took the derivative of that from and our original function is also all equal to 6. For our last example, we're going to look at the case where infinity comes into play. The limit of x approaching infinity of 4x squared minus 5x over 1 minus 3x squared is also equal to infinity, positive infinity, over a negative infinity, because 1 minus 3 times a very big number squared will equal a negative value. When we have a positive infinity over a negative infinity, it is also an indeterminate value. Therefore, we have to take the derivative of the top function, so 4x squared is 8x, and negative 5x is a negative 5, and the derivative of the bottom function, 1 minus 3x squared, is a negative 6. If we try to sub in the value of x being infinity, we see again that it equals positive infinity over negative infinity. So we have to take the derivative one more time using L'Hopital's rule. When taking the derivative one more time, we can see that 8x minus 5 is 8, and the derivative of negative 6x is negative 6. Therefore, the limit is negative 4 over 3. Because we use L'Hopital's rule, this means that the function that we took the derivative from, this one here, the limit of it is also negative 4 over 3, and the limit of the very first function is also negative 4 over 3. In conclusion, L'Hopital's rule is used when we have an indeterminate form. Also, the three conditions at the very beginning must be met. If the limit of the derivative of f of x over the derivative of g of x does not exist, then L'Hopital's rule cannot be used.